Well, this is the lab number 4. This lab is going to be about correlation and regression. So here we have some introduction for correlation, coefficient of determination, that is the R squared, the regression, all of that. I have talked about all of that in the corresponding video notes. All right, so let's go straight to the activity, to what we have to do in Minitab. It says lab, the forced expiratory volume, FEV, measured in liters, is a primary indicator of lung function and corresponds to the volume of air that can forcibly be blown out in the first second after full inspiration. The dataset large.FEV contains the FEV values of a large sample of children, age, height, and some categorical descriptors of each. We will use the data to study growth patterns in children. That file is an Excel file. It's already posted on Blackboard, on the corresponding module, on the folder of the lab. Yeah, the name is going to be that, large FEV. And here we have the description of the variables. First, compute summary statistics for the data, such as mean, standard deviation for the age, FEV, and height. All right, so go to Minitab. There you have. I already have here the file. Again, this file, this large.fev file, is already posted on Blackboard. So when you open it here, you have this data, and now we have to create first basic statistic, right? Mean, standard deviation for age, FEV, and height. So go here, stat, basic stat. Let me put it together. Here you have stat, basic stat, display descriptive. Stat, basic stat, display descriptive. We have to do it for age, FEV, and height. Remember, only for, you have to put here the variables in this box. Only you can double click. And statistics, well, I think we can use the only mean, standard deviation. Maybe you want the quartiles, minimum, maximum. I think this is enough by now. So I don't know if you are interested in other kind of measure. And then OK, and there you have mean, standard deviation, minimum. Notice how we have here is presented for each variable. Then a new measure is this one, the one of correlation. Correlation, how do we compute correlation? I have shown you how to do that in the video notes anyway. Is stat, basic stat, and correlation. Correlation for age and height, age, height, and then OK. And there you have, you see, you will have the scatter plot. But if you scroll down, you're going to find the correlation coefficient is 0.792 or 792. There you have. And here you have to respond to these questions. What are the correlation for the height and age? You have it there, 0.792. What happens to the correlation if you change the X and Y labels? Swap the order. It's going to be the same. Swap the order. Notice stat, basic stat, correlation. Instead of using age and height, write the height first. Height, and then H, and then OK. The correlation is the same. See that? The correlation is exactly the same. All right, next, plot the relationships, correlation of age and height by sex. Plot the relationship between age in years and height in inches in boys and girls in two separate graphs. On the menu, select graph scatter plot. All right, here these are indications. These instructions are given that you have actually the software that's saving your computer. I mean, remember that we're working here, well, with the one that I'm working here, and I think most of you, unless that you have the Minitab file or Minitab software in your computer, and we're working here with the option that YouTube allows. So it's only the web application or the web app for Minitab that we are allowed to use. So sometimes the instructions are going to be a little different, right? So anyway, I'm going to be here saying to you how to do it. But here we have to do a classification by sex. So go to scatterplot, graph, scatterplot, groups displayed, choose the option groups displayed separately. OK, and then type the option for y height, for x age, and the variable sex. And here should the app be sure that you should the option in separate panels of one graph. And there you have, and then OK. And there you have. You will have this this scatter plot along with the regression line. How well, I didn't mention how to do that, how to put the regression line. The regression line is, you can do it that with the correlation. Once you have the scatter plot, again go to graph, scatter plot, follow the same steps, but here in the box, in the button options, click this box, this little box, fit regression line. Fit regression line. That's what I did. That's why we have already here the regression line. Okay. There you have. Observe the pattern. Mac instruction. We can skip that. Question. Well, I think these questions are for you. Do the growth patterns look linear? Do the patterns look similar to each other? Respond by using your criterion. Now, the correlation of age and height by age range. The nonlinear pattern of growth over the whole age range suggests that we should study younger children, ages 10 and younger, separately from adolescents, ages 11 and older. Plot the relationship between age and height for the younger children, obtain the least square regression equation. This line. Notice here, if we follow the instructions exactly, yeah, we are supposed to do this by using the scatter plot, and then response, predictor, categorical variables, the same we have done before, and then we need to click in the button data option. The problem is that if you try to do that directly in this web app for Minitab, notice no button, right? No button, name, data options. So we cannot, from here, we cannot do these instructions. We cannot follow the instructions given here. So what can we do? Well, in this time we have to do it. We have to create a new worksheet. But how? All right. Notice we have to do data option, subset, rows, match condition. We have to do this separately. First, go to data here, subset worksheet. Choose this option, subset worksheet. And then follow instructions, use rows that match a condition. Do you want to include or exclude rows? Include rows that match the condition. For the column H, first we're going to focus on less than 11. So for all the numbers, all the elements in the column for H that are less than 11, choose the option less than and write 11. Be careful, do not include the value because we want strictly less than 11. And there you have. You want to, with this mini tab, it's going to create another worksheet. If you want to put the name, do it. If you don't want to do it, no problem. Mini tab is going to do it for you. So click OK. And if you see here in the mini tab portion of the screen, where we have a new file. Look at the tabs we have here. The first worksheet with the original FEB for adolescents, and the other one is the new one, age less than 11. So you have to do this first, that okay? Because we don't have the option for data option directly from the menu of the scatter plot. So once you have created this, now on this worksheet, follow these instructions. Is graph, scatter plot, group displayed separately, OK, hide age, sex in separate panels of one graph. I mean, it's the same we already have. And then click OK. And you're going to have the graphs for this worksheet. Is that okay? In this worksheet, we have only the data for age, but less than 11. All right. And then we continue with this MAC instruction. We can skip that. Now plot the relationship between age and height for the older children. Now this is for less than 11. Now we have go back to the main worksheet FEB, this one, and now create another subset worksheet. But now it's going to be greater or equal than 11. So only change the option, the condition here, leave the same as before, greater than 11. But this time include the value 11. Because before we had strictly less than 11, and here is time greater or equal than 11. And then okay. Notice another worksheet has been created. So in this worksheet, again, create this scatter plot, graph, scatter plot, group displayed separately, OK, the same, height, age, sex, separate panels, and then OK. And there you have, you see? This is based on the fact that the ages are only 11 or greater. And then questions. What are the least square regression equation for the younger? Well, in this case, we have to, for example, for the younger is for the previous scatter plot, this one. How do you know what is the regression equation? Well, only put the cursor above the given straight line in red. You see, it's 39.89 plus 2.277h. So do the same for the other cases. You can respond to these questions. What are the least square regression equation for the older children? The same. What percent of the variation in height is explained by these models? That is going to be determined by the coefficient R squared. Again, put the cursor and you can be able to see the coefficient. The R, this part, RSQ, 59.6%. Okay? So take that into account when you are responding to these questions here for these graphs and for the other scatter plot for the age greater than 11. All right, now finally, now examine the impact, launch capacity by age and smoking status. Now examine the impact of smoking on lung capacity for children in middle and high school ages 11 and up. So plot the relationship between FEV and age. So we have to do it. Notice it says ages 11 and up. So we have to work with this in the worksheet for greater than 11. Now we have to do again the scatter plot, graph, scatter plot, group displayed. But now we have to use FEP instead of height. Use FEP, age. But now in this case we don't have to use sex. We have to use smokers and non-smokers. So the variable is smoke. So here double click. Only one. Only smoke. That okay. Y variable FEP, X variable age, and then smoke, and then click OK. And there you have for smokers and non-smokers. Okay. And the same as before, you will have to respond to these questions. All right, so you can do that. Now, correlation and regression applet. Besides this Minitab, there is another interesting application. Well, it's called an applet that we can use to work with this scatter plot, but this is given in the internet. So follow this link, right? Follow this link. I'm going to open this link. Click here, and there you have. You're going to be directed to this part, and we have to follow the instructions here. Let me put this together. All right, so only this is simple to use. Only follow the instructions. It says, number 1, add about 20 points to the scatter plot by clicking repeatedly on the mouse. Try to draw an elliptical cloud of points with a positive linear association with a correlation coefficient at about 0.50. And then, so here we have to only click. You see? Only click. And you're going to be creating a pattern. And you're given the correlation coefficient. So we, again, try to follow the instruction. The correlation coefficient must be positive, must be close to 0.50. So do it like this. If you want to have a better correlation, so remember that they must be very close to a straight line. Well, I'm using more than 20, right? I'm sorry. So let me do it like that. So there you have. I think with that it's okay. So it's close to 0.50 and it's positive. Then select the step 2. Select show mean x and y lines. Click this box. There you have. Select the draw your own line. Click once, a blue dot in a green circle, and a green circle will appear. Click again somewhere else, a green line connecting the blue-green dot to a new green dot will appear. Using the mouse to click, drag, release, draw your best guess of the least square line. So here, essentially, you have to guess what the linear regression equation or the straight line of that equation is going to be. So we have draw your own line. So only click one button. One point, then the other one. And actually you can you can move the dots. You see that? So I think my guess is going to be this one. You have to do your own guess, of course. I think it's going to be this one. And then scroll down and select show least square line. So now, what is the real least square line? So click this box. There you have it, the line in blue, right? So was your initial guess close? I would say no. Is the least squares line flatter, smaller slope than your initial guess? Yeah. In this case, yeah. Because the slope has to be this line should be more close to the x-axis. That okay? The line in blue. So I would say if the least squares line flatter than your initial guess, I would say yes. Now for number 5, select add data. At the point, total of 21. Well, I have 31. On the far bottom right hand edge of the scatter plot. So I'm going to add another point. I know that I have 31, but I did it so I can meet this condition, right? But anyway, I'm going to include another one. It says add a point on the far bottom right. So it's going to be here, right? Far bottom right hand edge of the scatter plot. So it's going to be, I'm going to include it here in this part. There you have. What is now your correlation coefficient? In this case, my new correlation coefficient is 0.0763. So notice how this single point had a lot of influence in the correlation coefficient. You see, only that single point. Now drag the same point from the far bottom to the top right. So I'm going to put it here. Notice how we can modify we can move the points, and this at the same time the correlation coefficient on the line is changing, right? So this application is very good. So now drag the same point from the far bottom to the top right hand. I want to put it here. To the top right hand edge of the scatter plot. What is correlation coefficient? Now it changed from 0.07 to 0.6261, right? Now 6, use the mouse to add points to the scatter plot in such a way that the correlation is close to 0. So I think we do this. The line in blue is going to be almost horizontal, so let's try that. Add many points such that this number has to be very close to 0. So I'm going to be doing this. There you have. Very close to 0. What's happening to the line in blue is almost horizontal. And then you can respond to these questions, right? Which outlier? Remember that an outlier is a value that is very extreme to respect to the other values. All right, guys, that's all by now. See you in the next video.